Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 2, variant 1. In the last two videos, we have already discussed from question 1 to question 5. And in today's lesson, we will talk about remaining questions. Means we will talk about question 6 and question 7. Question 6 is about electricity and question 7 is about radioactivity. We will discuss these questions in detail as always we do, so you can improve your conceptual understanding of AS physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 6 says a metal wire in a circuit has a length of 1.8 meters and a cross-sectional area of 1.5 times 10 to minus 6 meters square. The total number of free electrons in the wire is 2.3 times 10 to 23. There is a current in the wire so that a charge of 172 coulombs moves past a fixed point in the wire in a time of 2.5 minutes. For part A, we need to show that the number density of free electrons in the wire is 8.5 times 10 to 28 per cubic meter. Number density. So first of all, let's try to understand what is number density. Number density is simply equal to number of free electrons per unit volume. So you need to be very clear about this one, number density. We denote number density with letter small n. Number density is equal to number of free electrons per unit volume. Number of free electrons are, you can say, charge carriers. Free electrons are, you can say, charge carriers per unit volume. So this is how we define number density. Simply we can say number of free electrons per total volume, total number of free electrons per total volume. So in this case we have total number of free electrons that is equal to 2.3 times 10 to 23. So we have this number of free electrons. We need to divide by volume of the wire. Length of the wire is given to us. The wire we are treating as a cylinder, so this is a cylindrical wire. So this is cylindrical wire. In this much volume we have these number of free electrons. Cross-sectional area of this one is A and the length of this wire is L. So we need to find out its number density, means the number of free electrons per unit volume. So we need to divide total number of free electrons by total volume of the wire. And volume of the wire will be equal to A times L, and L is given, that is equal to 1.8 meters, and cross-sectional area is 1.5 times 10 to minus 6. Now if we solve this one, we will get 8.5 times 10 to 28 per cubic meter. So this is the number density. And this question has only 1 mark. If you have got the right answer, you will get 1 A mark. Part B says calculate the average drift speed of the free electrons. In order to calculate average drift speed of the free electrons, simply we have to use transport equation. Means I is equal to NQVA. And V is the drift speed here. So we need to calculate V, so we can make V the subject. So V is equal to I divided by NQ times A. But in the question, I is not given to us. I is equal to Q divided by T. T is the time, and this is divided by NQA. Well, if Q is given to us in the question, now simply we need to plug in those values. 172 coulombs, and the time taken was given, that was equal to 2.5 minutes. So we have to convert this one into seconds. So this is 2.5 multiplied by 60, means we have to convert into seconds. And value of N we have just calculated, that was equal to 8.5 times 10 to 28. And Q is the charge on single charge carrier, means on single electron. So we can say this is 1.6 times 10 to minus 19 coulombs. And the value of A is also given in the question, and that is equal to 1.5 times 10 to minus 6 meters square. Now simply we need to solve this one. If we calculate, our final answer should be equal to 5.6 times 10 to minus 5 meters per second up to 2 SF, because the least number of SF in the raw data we have, that is equal to 2 SF. So our final answer also should have 2 SF. So this is our final answer. Question 7 says a battery of electromotive force 9.6 volts and negligible internal resistance is connected in series with two fixed resistors and a thermistor as shown in figure 7.1. The fixed resistors have resistance of 3400 ohms and 5800 ohms. The reading on the voltmeter is 6.0 volts. Calculate the current in the resistor of resistance 5800 ohms. So simply we need to calculate current passing through this resistor. So we can say we have to calculate value of this current. We can say this is I1. In order to calculate value of I1 simply we can connect a voltmeter in this way. So we have one voltmeter that is connected here. So let's say this is V and this is connected between these 2 points. Another voltmeter we can connect across this resistor. Let's say this one is V2. So this is our second voltmeter and this one is our first voltmeter. So in this case 9.6 volts mean EMF of the battery, this one has to be equal to V1 plus it has to be equal to V2. V1 in this case is given to us, that is equal to 6 volts, mean reading on this one and reading on this voltmeter, they are the same because they are connected between two same points. This is 6.0 volts, so we can say this is 6. We have to find value of I1, so V2 will be equal to I1 times resistance of this resistor, that is equal to 5800. Now simply we have to solve this one for I1. So I1 in this case we can write down, this one will be equal to 9.6 minus 6 divided by 5800. If we solve this one, we will get our final answer 6.2 times 10 to minus 4 ohms. So this is amount of current passing through this resistor and amount of current coming from this battery, that is also equal to I1, and this is equal to 6.2 times 10 to minus 4. We need to understand current entering a battery and leaving the battery has to be the same. For part B, we need to calculate the resistance of thermistor. Imagine that resistance of this resistor is equal to capital R. And in the previous question means in part A, we have already calculated amount of current coming from the battery, means I1 we have calculated. And the value of I1 was equal to 6.2 times 10 to minus 4 amps. And if you look at this junction, at this point there will be no current passing through this voltmeter because the resistance of ideal voltmeter is equal to infinity. So resistance of this voltmeter is infinite. So it simply means that current passing through this resistor and thermistor is the same. So it means they are connected in series. And if you look at this junction, there will be no current passing through this voltmeter because its resistance is infinite. So it also means that current passing through this resistor is also equal to I1. So it simply means that these three resistors, they are connected in series with this battery. So we can write down 9.6 EMF. This one has to be equal to total current in the circuit times the total resistance. So we have 3400 plus we have R plus we have 5800, and value of I1 we have, that is equal to 6.2 times 10 to minus 4, and here we have 3400 plus we have 5800 plus we have capital R. Now simply we need to calculate this one for R. If we solve, our answer should be 6.3 times 10 to 3 ohms. So this is resistance of thermistor. Pretty straightforward question. Don't get confused with this one. that some current is passing through this. No current is passing through this one because resistance of ideal voltmeter is infinite. Part C says the initial energy stored in the battery is 2.6 times 10 to 4 joules. Assume that EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 330 coulomb has moved through the battery. In order to answer this question, simply we need to understand the meaning of EMF. So we can write down here EMF. EMF is the amount of chemical energy converted into electrical energy per unit charge. It simply means that the amount of electrical energy supplied to each coulomb charge. Or we can say that EMF is equal to energy supplied per unit charge. So this is the main concept you need to answer this question, per unit charge. So we can also say if EMF is equal to 9.6 volts, what does it mean? It simply means that 9.6 joules of energy will be given by the battery to 1 coulomb charge. So this is meaning of 9.6 volts EMF. But for this question, we need to calculate final energy when this much charge passes through the battery. If 1 coulomb charge pass, battery will lose this much energy. If this much charge pass through the battery, how much energy battery will lose? That one we can simply calculate delta E lost. Delta E lost. So that one simply will be equal to 9.6 means EMF 9.6 joules divided by 1 coulomb. So this is the EMF, and we need to multiply with amount of charge, total amount of charge passing through the battery. So coulomb will be cancelled, so we can calculate amount of energy lost. That one will be equal to 3170 joules. But for this question we need to calculate final stored energy. So we can say delta E means the energy loss. This one will be equal to the initial energy minus final energy. Final energy is lower. That's the reason we are writing EI minus EF. Now simply we need to plug in values. So I'll be writing here delta E. So we can say delta E, this is equal to E initial minus E final. So this is delta lost. So E final from here will be equal to E initial minus energy loss, means delta E. So we have initial amount of energy that was stored in the battery, that is equal to 2.6 times 10 to 4. 2.6 times 10 to 4. And the energy lost we have 3170. So the remaining amount of energy we will have, that is equal to 2.3 times 10 to 4 joules. So this much energy is remaining in the battery after this amount of charge has passed through the battery. So this is meaning of EMF. So final answer is 2.3 times 10 to 4 joules. This is how you need to answer. Then this question has 2 marks. You will get 1 mark if you have calculated this energy. You will get 1 mark. That one will be C mark, and the final mark you will get if you have got this right answer. Part D says the environmental conditions change causing an increase in the resistance of the thermistor. State whether there is a decrease, increase or no change to the temperature of the thermistor. For this question it is given to us that resistance of the thermistor increases, so temperature has to decrease. And if resistance of thermistor decrease, it means temperature will increase. If you look at the curve for thermistor, resistance against temperature curve, let's say we have temperature on x-axis, the shape of the curve is like this. So it means when temperature is lower, resistance is higher, and when temperature is higher, resistance is lower. So simply in this case we need to write down temperature of the thermistor decrease. Current in the thermistor. Now we need to understand if resistance increase, mean this resistance increase. So how about the total resistance of the circuit? R total has to increase. Total resistance of the circuit increase. So it means that I total has to decrease because all these components, they are means these three resistors, thermistor and two resistors, they are connected in series, so current will decrease. So current in the thermistor decrease, so this one will decrease. Potential difference across thermistor, this point is little bit tricky one. For this purpose we can simply write down EMF, this one has to be equal to I times we have 3400 resistance plus we have I times R plus we have I times 5800 ohms. EMF is constant, current in this case decreases, but this one is constant, so it means overall here this V will decrease. And if we look at this one, resistance increases. First of all, let's look at this one. This resistance is constant, this current decreases. It means PD across this one also will decrease. We can say this is V1, we can say this is V2. So the PD across thermistor, it has to increase because EMF is constant. So in this case current decrease but resistance of thermistor increase. So overall, if I say this is V3, overall V3 has to increase. So we can simply say this one increases. So this is how you need to answer. Nice question about DC circuit. Question 8 says an isolated stationary nucleus X decays by emitting an alpha particle to form a nucleus Y. Nucleus Y and nucleus Z are isotopes of the same element. For part A, by comparing the number of protons in each nucleus, state and explain whether the charge of nucleus Y is less than, greater than, or the same as the charge of nucleus Z. If you look at the question, it is given to us that Y and Z, they are isotopes of the same element. Isotopes of any element, they have the same charge. So simply we can say they have same charge. Now we need to state why do they have the same charge? Because they have same number of protons in the nucleus. So they have same number of protons in the nucleus. So this is how we can answer this question. For the second part, we need to compare nucleus Y with nucleus X. But for this question, it is given to us nucleus X decays by emitting an alpha particle to form nucleus Y. It simply means that nucleus X forms nucleus Y by emitting alpha particle. We can also assume atomic number of X, Z and mass number of this one is A. So the atomic number of Y has to be Z minus 2 and its mass number has to be A minus 4. Now we need to understand what is meaning of minus 2. Minus 2 means that Y has 2 protons fewer than nucleus X. So it has 2 less protons. So we can say 2 protons less than X. 2 protons less than X. So it simply means that Y has less charge. So we can simply say less charge on Y. Less charge on Y. Now we need to explain why less charge on Y. Because Y has 2 fewer protons than X. Protons than X. So that's the reason Y has less amount of charge. Part B says use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of nucleus X. A typical type of question, you will see this question in many past papers. So try to master how to approach this type of problems. In order to answer this question, imagine that we have nucleus X and this nucleus is at rest initially. So the initial momentum of this one is equal to 0. And this nucleus X becomes nucleus Y by emitting alpha particle. So we have here nucleus Y and here we have alpha particle. So this is alpha particle. Alpha particle is emitted from the nucleus X. It means alpha particle must have some speed. So we can say it has certain speed. Let's say its speed is V alpha. So in this case, now you need to understand for the momentum to be 0, for the final momentum has to be equal to 0. So if we use conservation of momentum, final momentum also has to be equal to 0, and final momentum can only be 0 if these two particles, they have equal and opposite momentum. We can also imagine that, let's say this particle moves to the left. We can say its speed is Vy and its mass is my, and mass of alpha particle is m alpha. So we can simply write on here, we have to take one direction as positive. So in this case we are taking to the right is positive. So we have momentum of alpha particle, and this momentum has to be negative. So here we have my and here we have Vy. From here, if we solve this one for Vy, we will get Vy is equal to m alpha times V alpha divided by my. As Vy is positive, it means that our assumption is correct. So y has to move to the left. So these are the points you need to understand to answer this question. Very basic question and also a typical type of question. Let me show you how you can write down your answer. In your final answer, you have to mention these points. You can say total momentum before decay is 0. So total momentum after decay must be 0 as well. So y must have equal and opposite momentum to alpha particle, because in this isolated system we have only two particles after decay. So the momentum has to be equal and opposite. So y cannot be stationary. And that's all for today's video. We have done whole paper. I hope this paper was helpful. If this paper was helpful, please like and subscribe, because your encouragement is very important. And I'll be uploading paper 2 variant 2 from May June 2023 very soon. See you in next video.